Welcome to the Opal Special Awards Program for Innovation, dedicated to outstanding firms and designers. The Special Award nominees were exclusively chosen by our judges. Innovation defines and shapes the future through the use of new technology and design principles, an inspiration to our future generations. And now, the winner of 2021 Opal Special Award in Innovation goes to
the 2021 Opal Special Award for Innovation, Werner Sobek for his Gradienten Beton.
So, Mr. Sobek, congratulations winning the Opal Innovation Award for the graded concrete. And I would like to ask you a little bit to tell us what's the thinking behind the graded concrete, how does it work, but also what drove this development, this innovation that you're behind.
So first of all, thank you very much for the honor of getting this award. What is graded concrete? In simple words, it is concrete with cavities inside. So you don't see the cavities of different shape and density from outside. And the result is that the cavities yield to a less weight of a building element, which weighs up to 50% less than to a comparable one of the same exterior size. And that means at the end that you save 50% of building material and everything which comes along with that. So the emissions caused by the production of those building materials, the size of the foundations needed to carry the weight of such a building element into the ground, etc., etc. This is the background.
And then, of course, it also has this aspect that you create something which is easily reusable or recyclable in terms of a single material fraction. Could you explain a little bit about the potential in that?
Yeah, this is a very important issue for me. There are solutions out there in the so-called practice since many decades where people embed plastic spheres or other plastic elements into the concrete, thus creating something which is not decomposable at all, at least with acceptable effort. And for me, it was quite clear to do two things in this more than 20-year lasting development. The first issue is that it had to be 100% recyclable in easy way. So the hollow spheres or the hollow element or called cavities, which we lay into the formwork or which we integrate into the building components are made of concrete by themselves in a special mixture and of course with low diameter aggregates so that we result in a thinness of 2 to 4 millimeters for those elements to be embedded before we pour or spray the concrete. So the final product is just concrete, easy to be recycled.
So the use of graded concrete, do you see that as something that potentially could replace all sorts of applications like in concrete slabs, or is it more in specific areas?
The big advantage occurs in concrete slabs. And if we consider that the concrete slabs cover 50 to 60% of the entire weight of a building, the savings are remarkable. Of course, in certain types of shear walls or cores also, we could also apply graded concrete.
Okay. And lastly, I'm thinking, so as you pointed out, it's a lightweight, it's a way of reducing the weight of construction. So besides the material savings and of course the emissions embodied in those, do you see any potential for a different way of constructing because of the lightness of the material?
Yeah, on the one hand side, the lifting devices on site and the material to be transported onto the site, which causes, of course, a lot of traffic when we look at urban situations, makes building much more easy than before. But I see it from a multilateral aspect background. So there's on the one hand side, the saving of material itself, of resources, And everyone knows that we are running out of resources, at least in certain parts of the world, out of gravel, out of sand, etc. So this is a big contribution to it. The second is reducing the emissions, especially in the production of the cement. It's a big contribution. The third is the emissions caused, and this is something mostly forgotten, the emissions caused by the transport of the material to the site, and at the end of our building's life, the waste transport from the site to wherever you bring it. And this is again a great reduction of emissions. So we have multiple advantages which all fall together with this one solution, which took me more than 20 years to develop it. Because the question at the beginning was, okay, there's an idea, but how do you know where to design which shape and density of cavity? Second question is, how do you, from the standpoint of a structural engineer, calculate this type of Swiss cheese? And third question, how do you produce it in order to be competitive and sense making? And in the meantime, we solved all the three aspects, and we are now facing our first projects to be realized in the upcoming year.
That's exciting, and we're looking forward to that. And we will actually be collaborating on a project, so we're very happy to be a part of that too. So thank you for this conversation, and congratulations again.
Thank you, Julian.